Okay, for this first video on the identities, I'm going to, hopefully you have your identities here, this worksheet. We already covered this in part one of identities. Now we're going to look at these Pythagorean identities. And I'll explain it on a separate piece of paper, and when you come back and look at this, it'll make a little bit more sense. Okay, so here we go. Copy this down. Pythagorean, just like the Pythagorean theorem. Pythagorean identities. Right, just like the Pythagorean theorem. Remember, the Pythagorean theorem is what? Anything that's Pythagorean, where you hear this word Pythagorean, it's just like the Pythagorean theorem. Remember, that's a squared something squared plus something squared equals something squared. That's the Pythagorean theorem. But remember, that's for triangles. But the reason why they still identify these as Pythagorean is because it is something squared plus something squared equals, and 1 is also 1 squared. It's in this Pythagorean format. So there's one here. This is the most popular one. Cosine squared plus sine squared, or actually I like to say sine squared plus cosine squared equals 1, right? The order for addition doesn't matter. And then there's these other two here that are not as popular, but they are still Pythagorean. Okay, and I'm going to rewrite it a different way, where I'll write the secant squared first, but I'll explain why this actually means all of this, okay, in the notes right now. So it looks like there's like 1, 2, 3, 4, 5. No, there's not 1, 2, 3, 4, 5. It's really 1. It's really this one, but from this one you can derive some of these other ones. Okay, so I'll explain that now. Okay. The Pythagorean identity, this most popular one, is sine squared plus cosine squared equals 1. This is the main one right here. This is the main one right here. And from here, I can get to other ones. All right, it's really the same thing. Now, if I solve for cosine squared and I leave this cosine squared, I'll have what? Cosine squared equals, I still have the cosine squared and I have equals 1. But if I move this sine squared to the other side, you'd get what? Cosine squared equals 1, what? Minus sine squared, right? You see? It's this same one. I'm just solving for cosine squared. Right? Same one, just getting the sine squared, which is positive here. When you move it over to that side, it becomes negative. So are these two different formulas? No, this one is being derived from this one. It's the same one. It's just another form of it, right? So here is another look of this same formula. That's if I solve for cosine squared. What if I solve for sine squared? What if I leave the sine squared on this side of the equal sign? And now you move the cosine squared over to the other side. Well, I got sine squared equals, the 1 is still over here. Right? Sine squared equals 1. And now this positive cosine squared, when you move it to the other side, is what? Right? So is this 3 different formulas? No. No. This is the main one. This one's the main one, but from here I can write it this way if I solve for cosine squared, or I can write it this way. Okay? And that's what you see here. Remember, they wrote cosine squared plus sine squared, but it doesn't matter. Sine squared plus cosine squared equals 1. And then here they solve for sine squared. And then over here they solve for cosine squared. This other bit, we're not going to get into this fancy business, but all they're doing is here, once you have sine squared, they just square root both sides, and then you get an additional formula. But we're not doing all those. We're just going solving for sine squared, solving for cosine squared. But it's really just this one. Okay, so that's One main one, the most popular one, sine squared plus cosine squared equals 1. These other two are not as popular, but just remember, anytime you see something with a squared and a 1, something with a squared and a 1, something with a squared and a 1, it's these Pythagorean identities. But this one's the main one. Let me copy this over. I'm going to write it a different way. Well, let's see. You know what? I'll keep it the same. From this one, it's what? 1 plus tangent squared is equal to what? Secant squared. Okay, that's another one. Right, that's another one here. And from here, again, there's also two ways I can look at this. And what are the two ways I can, what's another couple of ways, just the way we split this up, what's another way you can rewrite this? Well, I can solve for tan squared. If I just solve for tan squared and leave this here and I move this here, wouldn't this be tan squared is equal to what? Secant squared, right? Tan squared is equal to secant squared. And this positive one, when you move it over to that side, would be what? Minus 1. So this is another form of this one, right? It's just moving the 1 over to that side. It's not two different formulas, right? And then what if I keep this 1 here and I move the tan squared over? What's another form of this? Here, see, now it's going to be equal to 1. So that's going to be what? 1 is equal to, if I keep the 1 here and I move the tangent squared over, that'll be 1 is equal to secant squared theta minus, right? This is a plus 10, but when you move it over, it's minus 10 squared. Okay, so again, is this 3 formulas? No. It's this same one, but you can rewrite it, right? If you leave the tangent squared here, you move this over, you get this one. If you leave the 1 here and you move the tangent squared over, you get this. Okay, but you have your formula sheet or have your notes. Okay, so that way you're not going to memorize all these. You can just know how they look. Okay, the last one here is this one here has a cotangent. Again, when you see any of these, it has a squared and another squared and a 1, right? 1 is also 1 squared. Look at these Pythagorean identities. Here's this last one. This last one is 1 plus cotangent squared is equal to what? Cosecant squared. All right, this is the main one. Sometimes in some other books they'll make this one the main one, but I mean they're all the same, right? It's all one same one. They're not 3 different ones. Okay, so what can we do here? Well, let me solve for, keep the cotangent squared here. If I keep the cotangent squared here, that'll be cotangent squared theta is equal to what? Cosecant squared theta. That means I move the positive 1 over, that's going to be minus 1. Here's another form of that one. Okay, then this one I kept the cotangent squared here. Now, what if I keep the 1 and I move this over? Well, then the other form of this would be what? Well, keeping the 1 here, that would be 1 is equal to what? 1 is equal to cosecant squared theta. Now this positive cotangent squared, you move it to the other side, will be what? Minus. So again, just have your notes with you or have your worksheet with you, right? And again, just remember, whenever you see something squared with another something squared, right? Sometimes you'll have them subtracting, it equals to 1. subtracting is equal to 1. In this case, adding is equal to 1. Or if it's 1 minus or something squared. Again, you see something squared with a 1 or something, it's going to be connected to these identities. Okay, we're going to use these, and I'll show you in the next video the examples and how you're going to apply these. Okay, there you go.